if I write this word down, if I say unit circle, why is that word important? Unit. So this is the origin here, that's 0, 0. Which is 1 unit from the origin. So from here to here, it's 1. What that means is any radius here has a measurement of 1. This is 1, that's 1. This will be 1. So the unit represents your radius of 1 unit. Now what that means is if I draw a right triangle here, I should be able to find these measurements. So let's say, what are the coordinates of this point right here? So x and y. This is y, and then from here to here, that's x. And then this angle here is theta. You remember that from trig? You'll agree with me. X squared plus y squared equals 1 squared, correct? Pythagorean theorem. So this is called the Pythagorean identity. X squared plus y squared equals 1. You remember SOHCAHTOA? SOHCAHTOA. All right, so again, we have a radius of 1 here. That's our theta. Now, we have x here, y here. Let's play around with SOHCAHTOA. Theta, 1, x, and y. So sine of theta equals opposite over hypotenuse. Well, in our triangle here, what does that equal? Well, opposite is just that there, so that would be y over hypotenuse is 1. So the sine of our angle here is actually just going to be y. So whatever our y value is, sine theta equals y. So I'm looking for the measurement. Whoops. Sine theta equals y. Our y measurement is just sine theta. Our x measurement, cosine theta, adjacent over hypotenuse. So adjacent is right here, it's touching it. So adjacent over hypotenuse equals x over 1, which is just x. So cosine of theta here equals x. Again, this is what we're going to use to find measurements. Sometimes when you see this right triangle in the circle, you might just see this. Oh, this is cosine theta. This is sine theta. They mean this here, that's cosine theta. This here is sine theta, because you're going to get a measurement. But then, okay, we did this. Oh, wait, what about this guy? Tangent is right here. So tangent theta is, isn't that opposite over adjacent? So yeah, so it's y over x, exactly, y over x. And don't we know what y and x equal now? We know y is sine theta, x is cosine theta. So then tangent is sine theta over cosine theta. So these are the 3 most important things to know when we're dealing with the unit circle here, right? This here. Do you understand what I'm doing if I write that? So it's first quadrant, yes. Quadrant number 1. Right, see what Katie wrote? X is positive, y is positive, exactly. Because all your positive values on the x are on this side here. Positive values of y are up here. Then if I know that, I can say, okay, in quadrant 2, then 3, and 4. So I know here on the left side, x is negative, but y is still positive. In this quadrant, they're both negative, positive, negative, like that. So you see here, since sine is y is positive here, and y is positive here. So in quadrants 1 and 2, sine is positive. And we'll talk about that after we do this. So here I got theta here. All right. Now we know this is 1 that never changes because it's the unit circle. Hypotenuse is 1. What if I said, let's make this 30 degrees. We know that's 1. This is 30. So this is 30. This is 90. We know that's 60 because it adds up to 180. Now we can find x and y. So it's x, it's y. This is a 30, 60, 90 special right triangle. So for the 30 degrees, the side opposite of it is a short side because 30 degrees doesn't open as much as 60. So this is the short side for 30, 60, 90. I can't spell today. Short side is going to be the hypotenuse divided by 2. So half the hypotenuse. I'll write it better. I'll do like this, 1/2 hypotenuse. That means here, y equals 1/2, because half of 1 is 1/2. The long side, which is x, this is the long side equals the short side times square root of 3. So it'll be 1/2 times root 3, which gives us root 3 over 2. So then this is root 3 over 2 here. This is 1/2. So my coordinate up here would be xy, which is root 3 over 2, 1/2. So good question. So look, he just said, wouldn't sine the 30 be, yeah, so, root 3. So it's a property of a 30, 60, 90 triangle. All 30, 60, 90s have a root 3 in them. The short side is 1/2 the hypotenuse. The long side is root 3 times the short side. And so if I wanted to find sine of 30 degrees, that would just be, was it opposite over hypotenuse, 1/2 over 1. Again, that's going to be 1/2. But remember, since we said sine of theta equals y, we don't need to do all this math here. We can just say, since we know cosine of theta, or 30 degrees here, equals x, whatever we get here for cosine is going to be on this triangle. So it's right here. Cosine is x, sine is y. Sine, cosine. So then this is root 3 over 2, because we already know the measurements on the triangle. Because we just said, let me go back one. We just said here that cosine equals x, sine equals y. That's telling us to do less math. And then tangent of 30 degrees, we said that was sine over cosine. I'll just write that here, sine over cosine. We got 1/2 over root 3 over 2. Now here we have to do a little bit of simple baby math. You take the denominator reciprocal multiplied by the numerator. So 1/2 times 2 over root 3. And then he said that cancels out. So we're left with 1 over root 3. And then if you rationalize it, you get root 3 over 3. If you're wondering how I got this, to rationalize this, you have to multiply top and bottom by root 3 over root 3, like that. Just give you root 3 over 3. So this is tangent, cosine, sine. All right, because I only have one size triangle, we're just going to pretend that this is going to be 45 degrees. We're going to say, what are our values here? Our x and our y. We know this is going to be plus plus. So everything here in first quadrant is positive. But I'm saying, what are our values for x and y going to be here? Our actual coordinates here and here. Right, we're going to want to do sine 45 and cosine 45. The problem is, we need to know what the measurements on the triangle are. Because this is 1. And if it's 45 here, that's 45, which means these two are equal. So I can say, oh, a and a. So a squared plus a squared equals 1 squared. 2a squared, because it's an a squared plus an a squared. We have 2 of them now. 1 squared equals 1. Get a by itself. Divide by 2. A squared equals 1 over 2, 1/2. Square root both sides. So now you have a equals square root of 1/2, which is going to be square root of 1 over square root of 2, which is equal to 1 square root of 2. Got to rationalize that, and you'll get root 2 over 2, which means both x and y, since they're the same, they both equal root 2 over 2. And so this is our coordinate for this point. That's what I'm doing. 2 over 2. And they're both positive because they're in the first quadrant. So now this is easy. So if you have a 45-degree angle here, what's our y equal? Oh, root 2 over 2. Cosine, oh, same thing. X is root 2 over 2. And then here's a trick question. Last time I asked this, nobody got this right. That made me sad. So 45, we're going to have sine over cosine. It's a trick question. What is this going to equal? It looks like it's complicated math, but it's not. What does that equal? Yes, it equals 1. Yeah, I had some students one class trying to do some advanced calculus. Well, what are you doing? It's just a fraction with the same thing on top and bottom. So it's 1. So we know sine, we know cosine, and now we know tangent. So if I write 60 here, 1. So what's that going to be? If this is 60, that means this is 30. That's 1. Now this is the short side. This is the long side. We already have our values here. We just need to switch them up. So our long side was root 3 over 2. So put that here. Right, and so now the short side, we got 1/2. So now x and y just interchange each other. So now that means that x is now 1/2, y is root 3 over 2. And to give you an idea of what we have here, if I can make a little smaller circle, I'll draw it this time. So if this is 30, let's say that'll be 30, you'll notice that the y is short, the x is long. Now 60 is up here, that means the x is short and the y is long. X is down here. So the y is long, x is short, like that. So that means these two triangles are just changing sides. That's why it's been flipped 1/2, square root of 3 over 2. The other one was square root of 3 over 2, 1/2. So then I can say, I don't have to do any math. I can just say, okay, cosine theta equals 1/2. Sine theta equals square root of 3 over 2. And then tangent theta, yeah, this is the math that I think makes the most sense to people because it's visual. So tangent theta is going to be y over x, root 3 over 2 over 1/2. But wait, we don't need to do any math with this, do we? Let's go back. Because we already said tangent, where is it? Right here. We got root 3 over 3. So with this one, when it's 30 degrees, we get root 3 over 3. Or we get this, which is the same thing. So if I know with the previous one, if I got 1 over root 3 with the previous one, and this triangle is now flipped, this is going to equal root 3 over 1, which equals root 3. So now we have all 3 of our measurements. Let me see. So I got 30, 60, 45. I think I'm missing 2 more angles, the easiest angles. If I put an angle here, and then here, this one would be 0 degrees. This one would be 90 degrees. Well, that means our point is right here, and the point is right here. And if we know that these are the radii, they're both 1, I know the coordinates. That's 1, 0. This one is 0, 1. I can get my measurements. So for this one, cosine of 0 degrees equals 1. Sine of 0 degrees equals 0. Tangent of 0 degrees equals, oh look, 0 over 1. 0 over 1, which is 0. So let's look at this one now. Here, cosine of 90 equals 0. Sine of 90 equals 1. But tangent of 90, that equals 1 over 0. And that one's undefined. Because remember in the very beginning I said this, x squared plus y squared equals 1. We saw that because it's a Pythagorean theorem. Well, now we know x is cosine, y is sine. That's where this comes from. Whoops. Cosine squared theta plus sine squared theta equals 1.